Can you all hear me okay? Cool. So I'm Andrew Hoffman, as Glenn introduced me, so thanks for the introduction. I'm a senior security engineer at Salesforce.com, and I work on all the core application technology that powers the Lightning UI. Before we go anywhere, though, I was told that I'm required to get you all to read this slide. Essentially what it says is everything that I say here does not reflect Salesforce, but instead reflects my opinions of Salesforce. So read through that really quickly. I'll give you about 5 seconds. Is everybody done? Cool. So like I said, I'm a senior product security engineer over here at Salesforce. I work on the core application stack. That's LWC, Aura, Visualforce, and basically anything else that powers the Lightning experience. Previously, I worked on Locker Service, now known as Lightning Locker, which is our UI security library, which provides namespace isolation capabilities that pretty much aren't found anywhere else on the web. Are any of you here Aura or LWC developers? Are all of you familiar with Lightning Locker or Locker Service? Have you found it easy to work with? OK, well, we can talk more about that. Previous to this, I was actually an Aura developer, so I know your pain, and I think it's actually gotten very good in the last few years, but there was a rough period, that's for sure. And the final thing I want to say here was if anyone needs to get in contact with me, you can see right there. Easiest way is LinkedIn. I'm always looking for new internet friends, so feel free. So this talk is going to be about 40 minutes, and it's going to cover a couple things. Because this is a 40-minute breakout session, and we weren't sure that everyone here would be very familiar with LWC, we decided to split it into 3 main topics. So this is going to be a couple ways that you can write more secure LWC applications. And then after that, we're going to cover some general security best practices. And if there's time, we're going to go into questions and comments at the very end. So please hold your questions and comments until the end, just so we can make sure we get through all the content. And I figured we'd start off with a brief introduction to Lightning Web Components and talk about the advantages that Lightning Web Components has over other frameworks, mostly in the open source world, which is where its competitors come from. So for the few of you that are not Aura developers or LWC developers, LWC is a single-page application framework. So this lets you build complex desktop-like applications in the browser. These are applications built with reusable components that are composable, instantiable, extendable. They have their own component lifecycle, so they manage their own state, and they re-render whenever that state is modified. And they offer a number of things that are pretty interesting because they reduce the amount of time it would take to develop a complex application, like the binding of JavaScript data to HTML views, and the ability to make that data reactive. So whenever it's updated in the JavaScript state, it's reflected in the UI. You'll see at the bottom there, well, actually, on my screen right here, it's there, but yours should be right about there. There's a lot of competitors out there. This is kind of a big space right now. The 2 biggest ones are Vue and React. You'll probably find that LWC actually has a lot of similarities with Vue. There's some history there. Ember, Backbone, Angular were popular about 5 years ago and have fallen out of popularity a little bit, but are still around. So what makes LWC different than the competitors you saw on the last slide? Well, the big thing is there's a lot of integrations with Salesforce that you get with LWC right out of the box. So with LWC, you can use an annotation called @apex, and you can very easily generate queries that target your Apex controllers without actually having to write any XML HTTP requests, without having to worry about having the right headers, et cetera. LWC also has a service called Wire Service, which will keep your data in the UI up to date without any polling or sockets or anything needed. So it'll synchronize your UI data with the data in your Salesforce server or your Salesforce database. And LWC is unique in that you can combine components that you write with components that other developers write, potentially from other organizations, And you might get these through the App Store or something like that. And even though they run on the same page, the data and state inside a component that you own will not be able to modify or access the data and state in a component that's owned by another developer. So there's an interesting layer of security there. That layer of security comes through Lightning Locker Service. Previously, this was actually just Locker Service. I should update this slide because now we're calling it Lightning Locker, so that everything starts with Lightning. And Locker Service, like I mentioned prior, is a namespace isolation or sandboxing library that allows you to put components in the same page and compose these components and not have to worry about one component accessing or modifying the data or state, including the DOM tree of another component that's owned by another namespace. So this is really cool. This is how you're able to use AppExchange apps on the same page as your own apps without risking the loss of your data, your records, like you would in almost any other web application. So I'm gonna jump into the security best practices pretty soon, but if you want to learn a little bit more about LWC, we have a great documentation site that has live examples that you can fiddle with, kind of like JS Fiddle or JS Bin, LWC.dev. There's also a good trailhead that I would suggest taking. This trailhead not only walks you through writing a very simple LWC component, but it deploys it to the Salesforce ecosystem using the SFDX command line tools. So LWC.dev is good for learning LWC in isolation. The trailhead is if you want to learn LWC and you want to learn how to apply that and deploy it to a Salesforce org. There's a couple other talks happening here at Dreamforce that I'd suggest checking out. If you're an Aura developer especially, enterprise migration from Aura to LWC and Lightning Web Applications, Lightning Web Components for Aura developers. So without further ado, let's get into some ways to improve the security of your LWC components. So the first topic I want to talk about is secure DOM manipulation. This is basically a chapter on how to reduce the chance of cross-site scripting in the applications you write and deploy to Salesforce. And the reason I want to talk about this is because I actually have encountered this a lot when I'm helping our partners. A lot of times we have what's known as security office hours, and partners can come to us and they can ask us for assistance in the applications they're developing for the AppExchange. And we've seen a lot of instances where partners aren't manipulating the DOM correctly, and that leads to cross-site scripting vulnerabilities being introduced into their code, and we have to help them fix it. So with LWC, like I said, the framework's very powerful. Not only is the framework powerful, but it's fast, and it's quite secure. And when I say quite secure, I mean we've invested an enormous amount of money. I don't think I can tell you how much, but not only the Salesforce security team, but also security teams in various firms throughout the world have spent a lot of time trying to find holes in LWC. And of course, if they were to be found, they would be patched right away. So at this point in time, LWC is a very clean framework. And what that means is when there's functionality offered by LWC, you should probably use the LWC functionality rather than trying to rebuild it and implement your own. Here's some examples. When you have an LWC component, if you want to make a property in that LWC component reactive, you can mark it with @API. If you want to, API, let me see. Oh, that's actually for marking it as public. So if you want to make a property in an LWC component visible to its parent, mark it with API. If you want to make a private property reactive, you can mark it with @track. That means when the state is changed in your JavaScript code, it will be reflected in your HTML code. Public components, I believe, are reactive by default. You can use helpers like for each for iterations and if for conditionals. So that's pretty cool. These are a lot of things that you might do on your own in other frameworks or without a framework. And if you choose to let LWC manage the DOM for you, not only will you probably have better performance, but you're going to find that you have more reliable security as well. Here's a simple example. I have an LWC template. It's pseudo HTML. You'll notice there is a tag template, which isn't a valid HTML tag, but when this goes through the LWC XML parser, it is converted to valid HTML. And here I'm binding two attributes to the value and onChange attributes in the Lightning input element. So the onChange is, of course, an event handler, and the event handler is bound to a function, and the value is bound to attribute value, which is an empty string. If either of those were to change, well, actually, no, if the attribute value was to change, it would be reflected in the DOM immediately, pseudo real-time. There may be cases where you can't rely on LWC because some functionality that you want isn't there. And if that does occur, I would just suggest that you all do some Googling and pay attention to a lot of these XSS syncs that are common. A sync is a method usually provided by the browser JavaScript interpreter or by the DOM. And it's a method that either converts text to script and executes it, or converts text to DOM nodes and allows you to append those DOM nodes to an existing DOM tree, or even generate a full sub-DOM tree. And this is usually where developers mess up and accidentally allow their code that's supplied by, for example, another user, like a comment form, to result in script execution that was unintended. So I wanted to show you guys a little bit of a demo just so I can kind of like tie this together. Let's jump over to tab 1 over here. This is a very simple demo. You can see I have an LWC component that's running inside of the playground on Salesforce. And this LWC component has 2 iterations. And at the top right here, you can see that I'm relying on LWC to perform an iteration. Zoom in? Yes, I can do that. Here we go. Is that better? Cool. So I'm performing an iteration in LWC on the demographics, which is actually an array that is defined in the app.js. And at the bottom, I'm performing an iteration the old-fashioned way. I can't actually see the right-hand side of this. 1 second. I need to get my scroll bar back. Well, this is unfortunate. On the far right over here, there is the actual output of this. I think the monitor is not. I just want to get it out of full screen mode. Apparently, it doesn't want to go out of full screen mode. Well, if you check out this presentation afterwards, you can look at all the demos, and you can see the output of each demo, which is kind of the whole purpose of showing you a demo. Is Glenn here? OK, cool. I'll try, like, let's see, maybe I can move it over to this monitor, and then it goes into full screen, and then I pull it out of full screen, and then I push it back over to this monitor, and then I scroll. The zoom might be the problem. You might be right. It could just be a styling issue. Nope. I can't see the output. Very weird. Yeah, I see the run button. Oh, it's split? There we go. Awesome. Thank you, guys. Cool. So we got it working again. So let me just jump over to the JavaScript real quick. Right here, here's the array that we're using a for each to iterate on in LWC. And here's the old-fashioned way of doing it, which, of course, accomplishes the same thing, but is a little bit riskier, easier to mess up. We're creating a new DOM element. We're finding the parent element, which is myList. It's a CSS class selector. And we iterate through this demographics array. On each element, we create a new DOM element and append it to the myList. It's a lot of work. You don't have to do stuff like that in LWC. Just trust the framework. Let's get back to this presentation. Cool. So you learned a little bit about the power of LWC and how to avoid accidentally introducing cross-site scripting into your LWC applications. Well, how do you prevent components from intercepting your events? This is actually a really interesting one. So everyone knows, most people know that Lightning Locker prevents component state and DOM elements from being accessed via other components that do not share the same namespace. But what Lightning Locker does not do and cannot do is interrupt the regular flow of DOM events. So DOM events that are initiated by the browser propagate up a tree. This is the tree of components in the page, the tree of elements in the page. And on each component, at each part of the bubbling phase, they look for an event handler. And this includes bypassing any namespaces. And as a result of that, we really can't rely on them for secure component-to-component communication. You'll see there's a diagram on the far right over here. And this diagram kind of explains if component F at the very bottom is to initiate a browser DOM event, like onClick, what's going to happen is every component all the way up to the root element in the page is going to be checked to see if it has an onClick handler. And the only way to stop this is by actually handling the event mid-propagation and requesting, calling the function stop propagation on it. And if you don't do that, imagine you have a parent component or well beyond the parent component. There's a component that's owned by another namespace in the page, potentially an application that you've included, LWC component that you did not develop. That LWC component can intercept the event that was fired by component F. So we have a solution to this. LWC offers this really cool wrapper on the browser DOM event API. And these are called custom events. So they function very similarly to the default browser events, but they have some additional configuration parameters, and they're also initiated through the same API across all browsers. That's another issue with events that we won't get into here, but different browsers implement the DOM spec slightly differently. So these are much more reliable. And the two flags that are supported by the LWC Custom Events are bubbles and composed. So bubbles is cool because the bubbles flag allows you to actually decide if any bubbling should occur up the DOM tree. And this is useful because you might be in a situation where you only want the component to do local communication or sibling communication, but you don't want any parent objects to be able to access the data that you've put on your event. So if you set this flag to false, no bubbling occurs. If you set it to true, bubbling occurs. The second parameter that you can use is composed. So the composed flag determines if a custom event should be able to bypass the shadow DOM boundary after reaching the shadow root. LWC, for the sake of performance and compatibility, implements the shadow DOM spec, which is a specification for building reusable components in the browser. And it makes use of subtrees called shadow DOM trees. Each shadow DOM tree starts with a shadow root. You can imagine it as just a subtree that is totally owned by a single LWC component. And if you set the composed option to true, then what's going to happen is the events will be able to bypass that shadow DOM and continue propagation up the DOM tree. If you set it to false, the events will be constrained to the current shadow DOM tree. So this demo is kind of fun. Let me pull it up real quick. There we go. So this is a secure events demo. In this demo, I'm going to try to zoom in again, and hopefully I don't lose. There we go. Don't lose anything. We have a parent. The parent is called app, and this is an LWC component, of course. And the LWC component uses component composition to embed a child component right here. And it has handlers for event 1 and event 2. These handlers are handled in this JavaScript file right here. And it's very simple. All it does is assign the value of these two variables in the JavaScript state to the result of the event. And in fact, when it says event.detail, that's just a piece of data that's been attached to the event, another feature of the LWC Custom Events. And we've used the @track annotation, so this is reactive. So if these change, they will be reflected in the UI state. And if you look at child here, the child doesn't actually really do anything. It just implements composition with a grandchild class and passes the handlers again. And then the grandchild is where it's kind of interesting. The grandchild has these two buttons, dispatch event 1, dispatch event 2. If we jump over to the JavaScript over here, you can see that we're dispatching two events that are identical, with the exception being one bubbles and is composed, and the other does not bubble and is not composed. So if we try to dispatch event 1, you'll notice that nothing actually happens in the parent component, even though the parent component has a handler for event 1 and attempts to display event 1's data in the UI. On the other hand, because we've set the bubbles and composed flags to true in event 2, if we dispatch this event, it is represented in the app.js, the parent component, because it's bubbled up and been read by the event handler. So that's kind of a cool demonstration of how to use these configuration flags to make sure that the events that you're firing off are only read by the components you want to read your events. And I'm going to jump back over to the slides real quick. There we go. So the final tidbit of information that I wanted to give you to help write a little bit more secure Lightning Web components is CSP compatibility in LWC. So for those of you that don't know, CSP is a standard that's maintained by the W3C organization, and it's basically a configuration that websites can implement on an origin-by-origin basis to enhance, so tighten or even loosen the default security mechanisms enforced by the browser. It's very powerful, and it's supported by every major web browser. So that's Safari, Chrome, Edge, Firefox, etc. It's also very effective at preventing a number of common attacks against web applications. The downside is, if you're developing your LWC applications locally, so you're developing in a local sandbox, maybe you're developing using the browser-based playground tool, your components might not actually be compatible with a real live Salesforce org. Because once you introduce them to a real Salesforce org, you're going to be restricted by our CSP policies. So all I really said on this slide is, we've been auditing our CSP policy over time, and it's been quite a difficult experience because we permit developers to build on top of the Salesforce platform, but yet we want to make sure that our security is as tight as possible. So what we've done is we've made some modifications, and we built some tools on top of CSP in order to allow developers to develop without running into a lot of roadblocks that would be caused by CSP. We're also actively working on tightening CSP. And I think at the bottom I also said, there's some measures that we put on top of CSP to enhance the CSP experience. So the first thing in CSP is inline script. If you try to include an inline script, like in this screenshot below, I think it looks like the screenshot, I don't remember what I wrote, pulls in a script from some other page, so it's a dynamic load. After it does that, it pops up an alert box, says you got hacked. Didn't actually do anything, it just popped up an alert. But a lot of the cross-site scripting that we saw in the past came from the result of components pulling in their own script and executing their own script inline. And by blocking inline script in CSP, the browser forbids the loading of inline script. So we actually defer to them to implement these security controls the right way and consistently. And it works great. You'll also notice that if you try to manually create a script tag inside of LWC, the compiler will block it. So it's blocked in two places. The compiler will block the literal addition of a script tag to your template, and CSP will block a script tag that you try to load inside of a Salesforce org. Even if you could potentially bypass the compiler, find some way to dynamically generate a script tag, it'd be blocked by CSP. So don't use inline script. Dynamic script, on the other hand, is a little bit different. We've had a couple enterprise customers that have wanted to make use of dynamic script. Things like eval, things like document.implementation, et cetera. So what we did was, rather than blocking eval and dynamic script execution through CSP, we decided that we would wrap CSP. We would use Lightning Locker to generate a version of eval that is scoped to the namespace sandbox. So when your LWC component bootstraps, it bootstraps inside of a sandbox that's maintained by Lightning Locker. That's how you can have components from multiple developers on the same page. Now when this bootstraps, we offer you a wrapped version of eval, where you can take your strings and you can convert them to script and you can execute them against the JavaScript interpreter, but their execution context will be scoped to the current namespace and they will not be able to access the DOM or state from any other namespace. Very cool, this is radical. I would still suggest not using dynamic script if you don't have to, but if you do have to, you can make use of eval. And you can rest assured that if you break something, you will only break your own code versus breaking somebody else's code in their nearby components. Third-party APIs are available for Salesforce developers to consume, but they're available on a whitelist basis. This means if you want to make use of Twilio's API to send some spam phone calls, you probably shouldn't do that. If you want to make use of Twitter's API to automate some of your social media, anything like that, you can do it. You just have to actually go to setup in your Salesforce org. And from the setup, you can add URLs that will be whitelisted by CSP. When you do whitelist a URL by this method, the CSP will be changed to include the connect, frame, image, style, font, and media. So that means you'll be able to use iframes, you'll be able to use images, styles, et cetera, but you'll notice script is not in there. So whitelisting a third-party API does not enable the execution of script from that address. External scripts are only accessible from within static resources in Salesforce. This is very important. And the reason is because URLs reference locations, and they don't reference content. So we found that it's more secure for you to take a hard copy of whatever libraries you want to make use of. So if you want jQuery, take a copy of jQuery, upload it to static resources, and then use the secure Lightning loader to pull that into your code. Now, jQuery is very reliable, so it's unlikely that there would be an event where they would change the content of a file location on their server to something malicious. But you can rest assured that if you literally copy a file and you use static resources in order to make use of it, it's not going to change. And that's why we ensure that you have to use secure loading here. You can see it's only a couple lines. We have a load script function that ships with LWC. It's promisified, so you can use a callback when it's finished, and it's compatible with every major web browser. So you don't have to do any tweaking. And there's a little demo here, too, so I'll pull that up. The final demo is pretty simple. You can see I'm using the sandbox, so I'm not actually encountering Salesforce's real CSP policies, but I'm using eval here, and it's working fine. You can see that the document has the value test in the inner text under the element that contains the class title. So that's just a demo of using secure eval, so this is wrapped by Lightning Locker. And in the app.html2, if you were to uncomment this little block right here, you'd notice that the inline script would be blocked by the LWC compiler. So those are my 3 tips for writing more secure applications. Now we're going to move on to some general best practices since we have a little bit of time left. These are practices that you can apply not only to your LWC applications, but your Aura applications and almost any other type of application that you build. So you could call these engineering best practices or architecture best practices, whatever you want to call them. The first one, and one of the most important ones, is the principle of least privilege. This is a principle that says if you're building an application, and this application is comprised of many components, and each of these components has a different job, each of those components should only have access to the functionality required for them to work. I've seen this a lot when I've been helping partners with their applications. They'll build back-end services that have a lot of functionality, and they'll make use of those services in their UI. And sometimes that goes awry when they could have just written services that give the exact required minimum functionality to their client and been in a lot less trouble. This also applies to third-party integrations. The next thing I want to talk about was secure by default. This is a design principle that you can use when you're building not only LWC applications, but any other type of application. The idea is when you're presented an option between secure and insecure functionality, the secure functionality should always be the default. And beyond that, it should always be literal in the code. You can see here I wrote a little method on the left. This is just a JavaScript method that appends data to the DOM. And the default value for the insecure is false. It's literally called isInsecure. So if someone were to read through this code, they'd know, oh, this is secure by default. And if I want to do it the insecure way, I have to literally go through the effort of adding an extra parameter and telling it to do the insecure option. On the right-hand side, you'll notice that there's a function called unsafe component will update. This is actually a function in React, one of the competitor frameworks. But a cool thing that they do is any function that they consider to be somewhat unsafe or capable of introducing security vulnerabilities in their code, they label with unsafe. This means in order to call that function, you literally have to type unsafe and then call the function. And this is a great way of preventing developers from abusing insecure functionality in your application. The last two slides go along with separation of concerns. You probably all know this. Essentially what this means is if you're building an application, instead of building monolithic components, what you want to do is break them into the minimum viable component. I think I said if you're building a photo gallery application, you could build it all in one component, or you could break it into things like a grid layout that has no control over the state but only controls the layout. You could break it down into a photo that loads an individual photo, a layout manager to determine which layout to use, etc. And each time you break down your applications into smaller pieces, not only do you make it easier to debug your application, but you also reduce the risk of security vulnerabilities being introduced as a result of code pollution that occurs in monolithic applications. On the right, there's actually a pretty cool diagram I found on the web. Kind of shows on the left-hand side, you have an application that's monolithic, and on the right-hand side, you have an application that's been broken into smaller components, which is definitely preferable from both a security and a debugging perspective. Final thing I want to talk about that I've seen is a lot of Lightning developers don't properly audit their third-party dependencies. And in the JavaScript world, there's a lot of third-party dependencies. I mean, you guys probably all use NPM. You go and browse and try to find the library you want, and you find a dozen that accomplish the same thing. Well, your code is very important to audit, but also the third-party dependencies you pull into your code are very important to audit as well. And there's some cool tools out there. There's tools like checkmarks that you can make use of if you want to do static analysis on your third-party dependencies before you integrate them into your proprietary code base. And then there's also database tools like Sync that you can build into your continuous integration pipeline that will alert you if any known vulnerabilities in your dependencies are found. So if a security researcher on the web goes to a CVE database, a major one, and says, hey, I found an issue with jQuery or Lodash, it's reported, it's confirmed, Sync will alert you that that was found, and it'll tell you which one of your dependencies it was found in. So that's all my tips for today. It looks like we have about 5 minutes left. What I want you all to bring away from this is I want you to bring away the fact that LWC is our latest and greatest framework. It's actually quite fast, especially when you compare it to Aura. It's lightning fast. Lightning fast. We've been very carefully auditing it for security. We've had a lot of firms come and look at the code. So we're trying to do this the right way. When possible, you should defer to LWC's internal functionality instead of building your own. And make sure that as you're building LWC applications, you just keep in mind that you're building on the Salesforce platform, and we offer a lot of built-in security tooling, but you can always use some of those best practices to further improve the security of your organization. And that's about it. Does anyone have any questions? Yes, there's a microphone right there if you want to.
Hi. Does any of these would change in Canvas app, or would it all be applied, or additionally anything else would be, something applicable to Canvas apps as well?
Could you repeat that?
Canvas apps?
No, can you repeat the question?
No, the question is, how would all these applicable to Canvas apps? And then on top of it, will there be anything else?
Oh, so you're saying, you're talking about building apps on top of HTML5 Canvas.
Yeah.
Okay, and you're asking what?
Yeah, any of these
about this
factors would
applies.
be all same or something changes? Or
Yeah, so
additionally?
Lightning Locker is perfectly fine handling HTML5 Canvas. So you get the sandboxing and the isolation from Lightning Locker. I can't really speak to too much else on Canvas because I haven't made use of it, but if you have any specific questions, I would suggest actually emailing security@salesforce.com, and we can probably find someone in the Lightning engineering team that could answer specific questions about Canvas APIs.
Hello. I've had trouble trying to adjust the look and feel of standard Lightning web components using CSS or
Are you
really
talking
using
about
CSS.
the Lightning and Force namespace components that make use of SLDS?
Like Lightning-input, for example,
Yeah.
right? Trying to change the look of it other than just using the variant tag. Is this difficulty I'm having because of the shadow DOM or the security, or is there some way to modify using CSS how they look?
Encapsulation from a CSS perspective occurs as a result of the shadow DOM in the web component spec. We don't actually do anything around CSS. So any issues you're encountering with scoping are definitely going to be as a result of the shadow DOM encapsulating CSS. Now, I believe, I haven't made use of a lot of the standard components, but they usually offer configuration flags, right? Are there some that are missing?
Yeah, so most components offer like a variant option where you've got a limited series of options where you can change how it looks, but if you want to do something more than that, at least to me, it appears like you're kind of out of options other than rebuild the component yourself, making it look exactly how you'd like it to look.
If you need advanced functionality that the pre-built components can't offer you, what you always can do is you can make use of the SLDS styling library directly and implement your own components on top of the DOM. So you can just go to slds.com, I think it is, or something like that. Pull in SLDS style sheet, rewrite your own button.
Yeah, I think that's what I've found, is that seems like that's the only option, is to build your own version of the standard component.
Yeah, the standard components I know are out of the box are just to help you with rapid development, but they might not be as customizable as you'd want.
Okay, thank you.
Yeah.
I had a question regarding the external JavaScript libraries that you mentioned, and you mentioned that better to load that as a static resource. So sometimes when you do that, the library still gets blocked because it is in turn calling an external online resource.
So you're talking about JavaScript libraries that make use of dynamic script loading and pull in things from other websites, kind of like Google Analytics?
Yeah, right. So is there a solution to that? Because we had to solve it by making that as
That's a really big issue, actually, in the Salesforce platform. And we have a list of approved libraries that you can always contact security@salesforce.com. But outside of those approved libraries, I don't actually know of a good solution.
Okay, and also if there's a company policy restricting the use of static resources and directly accessing vetted libraries, then is there a solution to that, or it's a roadblock?
Could you repeat that?
So as part of our company policy, we have to use certain third-party libraries hosted and whitelisted versus doing it on a static resource. So is there a way to not use static resource and still use a hosted library?
There is no way at this time, but I would keep a lookout.
Okay, thank you.